Hey, Walter Sorrells back with another episode of the Folder Chronicles. Today I've got a new design and I'm going to talk about how it came to pass. So I haven't done a Folder Chronicles in quite a while. I introduced the X model folder earlier this year and I was just buried in it for a while. But now I'm coming out with a new model and I thought I'd share the story of that new model with you. So today is a story about the interplay between design on the one hand and manufacturing on the other. But it's also about the difference between custom or one-off type knife making and production work. So here is the new model. And here somewhere is the first version of it. They really look almost exactly the same. So how's that even a redesign? Similar profiles, blade shapes exactly the same. In fact, without examining them, you'd kind of be hard pressed to tell the difference between them, but they're actually very different knives. So let me back up and tell you a little about how this new design came to pass. For those of you who haven't followed my journey as a knife maker, I started out making one-off type knives and swords, especially swords actually, mostly Japanese style blades, probably about two decades ago. Then, about 5 years ago, I started my Tactics Armory line of knives. Whole different philosophy, basically modern, hard-use production type knives. Still made in my shop, mostly by me, but using high-end stainless steel, engineered materials, CNC manufacturing techniques, all that sort of thing. And originally, all of them were fixed blades. But I knew that I wanted to move towards folders eventually. You know, I carry fixed blades, I carry folders, I like both of them, there's a market for both of them. But one of the things that I recognized was that before I started making any folders, I wanted to be totally on top of the manufacturing side of things, understanding the CNC machines, which I had no background in at all. And it was easier to do that with simpler fixed blade type designs than with a folder. So anyway, last year I decided that I would start designing my first folder. Now you might think that either a knife design works or it doesn't. But in fact, it's really not like that. You know, obviously if I'd gone through the prototyping process and I'd ended up with a completely non-functional knife, it would have been time to start all over. But that's not what happened. Now, when you make a prototype, you tend to troubleshoot problems on the fly. In essence, the purpose of a prototype is to expose problems so that you can solve them. You have a problem with the tool path on your CNC machine, you fix it. You have a blade that wobbles, you fix it. You don't like the handle material, bust it off, put on another one, see how it works. Every design has flaws, and those just have to get stomped out in that prototyping process. But in manufacturing, there are also just little nuancy challenges where you have to make choices. This material is more durable but more expensive. This is cheaper but doesn't look as good. This machine's better, that doesn't. This feature looks cool, but that feature works better. This feature makes it smoother, but it's harder to make consistency. Choice after choice. And this is the key point. A lot of them don't have a correct solution per se. It's just a question of what the ultimate personality of the knife will be. But as you go through that prototyping process, making little changes, it's basically just kind of this game of whack-a-mole until everything's squared away and you have a bunch of functioning knives and a set of processes that seem stable to produce the knife that you're trying to make. So let's go back to the one-off versus production type approaches to knives. If you're making a one-off folding knife, which is the only kind that I'd ever made before I made the X, and you have a minor problem, then you just remake a part, you adjust something, you file a little bit here, cut a little there, you know, until you got something that's perfect. That's how all one-off knives are really made. It's very fiddly, and that's why handmade knives cost so much. So, having never put a folder into production, frankly, I just underestimated the gap between making a successful prototype, something you could hold in your hand, functioned, everything was right with it, and then actually going into production and making one after another like that. Obviously, I'd done that with fixed blade knives in the past, but a folder is just a different animal. So specifically, what I hadn't anticipated with my original X design was just how tricky it was to nest this little lock bar inside the frame. So ultimately I was able to, ship knives that function correctly, but it just took a ton of effort to get each lock bar absolutely perfectly situated. And I had a couple knives where lock bars came out of adjustment and I had to do warranty work on them. And, in the end, I just decided that I needed to eliminate this internal lock bar altogether. So the result, as I said, is this right here, the Mark II. So in the Mark II, I've ditched the internal lock bar and gone with a conventional liner lock design. I've found it to be much more predictable and hopefully much easier to consistently manufacture. The key point is because almost all of the critical tolerances are built into the liner itself, which incorporates the lock bar and a lot of other components, rather than being distributed between the liner, the blade, and the lock bar. There's just less to go wrong. Also, I beefed up the thickness of the lock bar, going from 60 thou thick titanium to 90 thou. That little change has a ton of advantages that I won't get into here, beyond just strength, but they all contribute both to manufacturability as well as to reliability and durability. Now, there's a concept in engineering called tolerance stacking. I hope I'm not going to get too nerdy on you here, but I think it's kind of interesting, so I'm going to hit you up with it anyway. So, every manufactured part in the world is made to a tolerance. In other words, there's a nominal size. Let's say you're drilling a 1-inch hole. There's a nominal size. And in our minds, we can say that there's a perfect 1 inch, but in the real world, there's no such thing as a perfect 1 inch. There's just how close can you come to it on any given operation, and then how close over multiple operations do you have to stay to that nominal every single time. So, if you're making a screw hole for some stamped metal mounting bracket or something, it might be fine if your tolerance is 1/4 of an inch. A lot of sloppiness and all that, that's okay for a mounting bracket. But if you're making a turbine shaft that turns at 300,000 RPM, maybe you need a tolerance down in the 10,000ths of an inch range. In either case, your theoretical, the nominal amount that you're making this hole to is exactly 1 inch. But in the real world, one has this really broad tolerance and the other has to be super, super tight. So let's say you're making a little widget of some sort that has, 5-6 parts to it. So the first part has some little critical area that has a tolerance of 1,000th of an inch, plus or minus. Meaning that, let's say it's a 1-inch hole, it could be 1 inch minus 1,000th, 999 thousandths of an inch, or you can make it up to 1 inch plus 1,000th of an inch. Anything beyond that's out of tolerance and you scrap the part. But as long as it fits into that range, plus or minus 1,000th of an inch, everything's cool. Okay, so let's say that part attaches to another part, and that attaches to another part, and that attaches to another part. And each of these parts have critical little measurements that interplay with each other that have a tolerance of 1,000th of an inch. So if each one of those parts was all the way out to the edge of that tolerance, 1,000th of an inch, you could end up with something being out of whack by 5,000ths of an inch at the end of that chain of tolerances, because each one stacks on top of the next one. And that might result in a widget that just doesn't function right. So that's what tolerance stacking is. The tricky issue with tolerance stacking is that every single product won't necessarily be messed up. All of those little deviations from the nominal might even out, but if all of them are out to the edge in a certain direction, then you run into trouble. In industry, they have very complicated mathematical ways of dealing with this, but in my little shop, no, that's not how it works. So anytime you have a whole bunch of little tolerances within a design that interplay with each other, you have to think about stacking. So with a liner lock folder, the tolerances that govern lockup, that's how tightly this thing goes into position and stays there. And then the tightness of that open and closed position so it doesn't, click or wobble around or whatever. All of those are interrelated because the detent ball is located on the lock bar. So basically I had a tolerance stacking issue. With that lock bar situated separately from the frame and from the blade, there were a whole bunch of different critical tolerances that would shift if that lock bar wasn't in exactly the right place. So some of them took a little bit of adjustment. Some of them were absolutely dead perfect from the get-go. And then some of them, you basically just had to trash one of the parts because it was just never going to work. So the bottom line is, I still actually love, where's the knife? Right here. I still love this knife. But in the end, it was a process fail. The knife's good, but the processes that are required to make each and every one of them right, I didn't get there. Obviously, I did my level best not to ship any that were defective, but the problem was that to get each one out the door, it was just really stressful, and it took a lot of time, a lot of fiddling. I might as well have been making one-off knives. The whole purpose of doing a production knife is that you can consistently put those knives out without having to fiddle to make them right. So is there a downside to this new design? Same profile, more or less the same thickness, just a little more titanium involved. Now that does mean there's a hair more weight and a little bit more expense in material, but it amounts to about the same amount of machining, and that machining time is actually a pretty important part of the cost of the knife. And best of all, there's way less fiddling to get it out the door in perfect shape. So, Mark II, more rigidity, more durability, more predictability in the manufacture. Onward and upward, right? Now, I've got a few projects I'm cleaning up before I get this into production, but I should have a few for sale maybe in the next month or so. Thanks for hanging with me. Story continues. See you soon. Thanks for watching, guys. If you feel like you got something out of this video, don't forget to subscribe. Also, click on the link to Patreon for a great way to give back to the channel. Plus, check me out on Instagram, Facebook, Twitter. Links in the description. If you want something sharp and pointy, maybe a gift for yourself or one of the cooler people in your life, check out my Tactics Armory website and pick up one of our tactical or outdoor knives. And finally, if you want to learn to make Hamones or Japanese swords, check out WalterSorrellsBlades.com, where you can find videos about how I make Hamones, as well as forging, mounting, polishing, and fittings for Japanese swords. Thanks, and see you soon.